Hi everyone, and once again welcome. And today I'm going to explain you one of the problems from IBDP physics pertaining to electrostatic force, numerical basic. Good one. And question says that positive charge Q is placed on the line joining Q1 and Q2, separated by a distance d. Find out the distance from Q1 where the charge Q experiences zero net force. Take 1 is equal to 2 microcoulomb, Q2 you take as 8 microcoulomb, and D you can take as. And the question represented the form of a diagram over here. Basically, about two charges, Q1 and Q. And Q1 is 2 microcoulomb and is 8 microcoulomb. You can see both charges are positive, right? Q1 and Q2 both are positive. Value of charges are 2 microcoulomb for 8 microcoulomb for Q2. Fine. Now these two charges are separated by a distance 3 centimeters between Q1 and Q. Now he has placed a charge Q somewhere between Q1 and Q, the line joining Q. And this particular charge Q has told that this placed in such a way that the net force acting on this Q, okay, is equal, right? So you have to find what is the distance from Q1, this particular. Okay. So let us get started. Now, basically, you can see that this particular arrangement can be divided in one is the charge Q and the Q. When you take a pair of this Q and Q, you get the force of repulsion. Q is a positive charge. Q is both being positive, there will be a force. That force will be equal to some constant A multiplied by Q, multiplied by Q, whole thing divided by distance square. Basically, the distance between Q should be equal to total distance is D, okay, D minus. I write this distance D. So divided by D minus X minus. Right? This is using your formula from the data sheet. F is A1 divided by R. F. Okay. So let us call this force as say F2. Repulsion force. Now, same way, F1 be a acting between this set, that is between Q and Q1. And that F1 will be again given by the same formula K. Time it will be 1 multiplied by Q divided now the distance between Q1 and Q. This will be the F1, and F1 force will be acting also a repulsion. Can you see these two forces? They are in opposite direction, right? Negative. Only the force acting in left hand side direction is 5. So we came to a conclusion that what F1 will be according to. Now he is telling you that due to this charge Q, the net force acting at this particular point where the is, find out the distance from Q1 where this charge Q is a zero net force. What is the meaning of zero net force? Meaning of this is your F1 plus F2 at the magnitude. Magnitude of this was only then the force, net force. So magnitudes will be in this. We are not concerned about the direction. So let us take FA minus F equal to A1 very nicely. I can cut A and K from both and Q. I'm left with on D minus X1. Is that correct? So that is what I get. Now this Q1 charge microcoulomb. Okay, so can I write 2 10 is to minus 6 upon X? X will be unknown. I'll write just this Q2 is given 8 microcoulomb. Right, very nicely. This has 8 into 10 is to divided by D minus X the whole square. D is given in centimeter. Centimeter will be equal to 0.0 meters. I am doing everything in coulombs and meter. Charge I am taking coulomb and I have to take charge in coulomb. It in SI system, right? This is 8 raised to minus 6 coulomb, okay? The 8 into 10 is to minus 6 was microcoulomb, right? 8 was microcoulomb. 10 is to minus 6. And 2 into 10 is to minus 6 microcoulomb. So, following the SI system, D also I have to take meters. I have taken charges in meters. So, D I will have to take 0.0. Take off take 3. This is where the student they take directly as and this they take in coulombs, okay, right? But you have to see that the units, meaning there should be conformity by the SI units. The charge should carry coulombs as unit and carry meter. Be D 0.0 minus X. Now basically we have got to the from this equation all we have to do X. This X is nothing but of that charge Q. Now we are supposed to X. So let me cut this 10 is to minus 6. Get down 8x square times. Now just simplify this particular equation. I go by this static 8x square into static 0.03 minus times 0.x x square. will 0.9 will be minus 2 left hand side. Everything if I bring on the right hand side, this will be 8x square minus 2 minus 0.2 plus 0.1, and this 0.0018 will be minus 0. You are getting a very good quadratic equation. All this quadratic equation x equal to minus plus or minus root of square minus 4ac thing divided by 2a. So in this case, your a is nothing but 6, b is a simple quadratic equation. Yes, c is minus 0. Plug these values over here so that x will be equal plus or minus root of square will be 0.1. This will be minus 4 times a is nothing but whole thing divided by 2 times a is 6 times 6. Works out to minus 2. To work out this entire thing under the square root, that is 576. Whole thing divided by 12. Right? We will get two values of x because it's a quadratic. One value will be x1 minus 0.1 plus square root of 0.0576. One value of x. Another value x2 minus 0.1 minus 0.2. It will be whole thing divided by 12. This should work out to minus into plus 12, and this will be minus 6 plus 130. Okay, so this will be nothing but 12 upon 100. Well, can be 12 upon 100 times. This should be minus 8 times 112. This should work out to 1 over 100, that is 0.0. This should work out as 3 over 100. This unit was taken everything in coulombs and meters. You get two values of x. One is x1 equal to 1 meter. Other one is x2 equal to 0, minus 0.0. But any distance cannot be taken as negative as a value of that distance. Okay, x2 0. Okay, negative number. Right? So we are ignoring this x2. Therefore, the x1 is the right answer. Therefore, we can say that the distance of Q from the charge Q, or you can say 1 centimeter. Centimeter it will be. So that was this particular numerical and made use of this electrostatic force. that is F equals AQ1. So that's all for today, and I hope you next time. I take care all of you.